In this video, we will investigate one of the more intriguing, difficult, but useful library in the Scala world, Scalaz. But before all, let's try to understand what is really this library. Scalaz is actually a large collection of typeclasses. To be more precise, it is a rewrite in Scala of the more complete typeclass library in existence, the Haskell library. I understand this answer, however, can actually lead to more questions. So, let's try to answer to the more obvious question: what is a typeclass? A typeclass in Scala is a pattern. You must follow a common and well-defined set of programming conventions to implement it. Typeclasses originated in the language Haskell, where they are a feature of the language. In Scala, they are not a primitive feature of the language in itself, because Scala offers the needed features to easily implement the concept. In Scala, a typeclass is thus implemented as a pattern. The purpose of a typeclass is somewhat similar to an interface. A typeclass defines a common set of methods that can be used to extend existing classes. However, implementing an interface requires you extend a class and implement the methods. Typeclass methods instead can be applied to existing instances without explicitly modifying the type. To implement a typeclass for a class, you need to create an instance of the typeclass. As we will see, typeclass instances provides the implementations for the methods defined in the typeclass. Furthermore, typeclasses as implemented in Scalaz are actually backed by a mathematical theory, the category theory. Typeclass names follows equivalent concepts in this theory. Because of their mathematical background, each typeclass in Scalaz requires the instances satisfy a set of laws. When you implement your instance, you need to verify the implementation satisfies those laws. Let's see what we talked about so far. I will show an example of a typeclass. We want to compare numbers and strings, using an operator that is not normally available for integers and strings. Of course, the application of such a method to numbers fails. The same holds true for strings. Now we can start to appreciate the power of Scalaz. First and before all, we need to load the library. With this command, we load the library for command line usage. We are using here the Ammonite Scala shell. We will use this shell in this presentation. You may use a different one, or just write the code in your development environment and compile it. Once you have the library available in your environment, you need to import it. Actually, it is all what is needed to enable Scalaz. The idiom of importing a package, then importing an object with the same name, is very common in Scala. Now, we can start to write code using Scalaz. Your code does not need any other modification. We are going to use a comparison operator, which belongs to the order typeclass. As you can see, without changing any code, the new operator is available for integers and can compare numerically integers. It will return an ordering value. In this case, the result means greater. The same operator works also for strings. Now, we have a new operator, which works comparing strings alphabetically. Let's see what happens when we define a custom class, as follows. Here is a case class defining a person with a name and an age. We created two instances, Andrea 20 years old, and Beatrice, a teenager. However, the two instances are not comparable. Using our new operator, we have to define how we want to handle the comparison of persons. A typeclass defines generically methods and operators. A typeclass instance defines how the typeclass behaves for a specific type. Here, we defined a new instance of the typeclass. We do not go yet into the details. The key is you need to pass a function, which defines how we want to compare two persons. We decided to compare persons using their name. As you can see, now two persons can be compared, and Andrea is lower than Beatrice, alphabetically speaking. Defining the ordering, you can use other methods in the order typeclass. We have now a working definition for the max operator for persons. We can change our mind and decide to order persons by their age. We redefine now the order with a new typeclass instance. This one is actually comparing persons looking at their ages. As expected, now Andrea is greater than Beatrice because he is older. Let's try to understand how a typeclass actually works. Since everything is based on implicits, the key is to discover how the implicits are expanded. Using a compiler switch, we can see how typeclasses are actually implemented. This is the code after implicits resolution. It is actually a two-step process. We will explain this process in detail in the following. Here is the code for the expansion of the custom typeclass instance. It is different because of the type, so it is using the typeclass instance we defined. The first step is to use an implicit conversion. Implicit conversions are invoked when no other options are available to the compiler. A single conversion function must match the types. The implicit conversion returns an instance of a wrapper class. It is this instance which provides the additional method we want. The actual implementation to use is provided by an implicit parameter, again matched by type. As you can see, for persons it uses the one we defined, while for integers it uses an instance provided with Scalaz. To really understand how the typeclasses actually works, we will implement one. We are going to implement an equivalent of the Java comparable interface as a typeclass. The advantage is obviously we do not have to implement a subclass in order to provide the functionality to existing types. A typeclass in Scala is implemented as a parametric trait. The trait have an abstract methods. You'll have to implement this method for each instance of the typeclass. Let's define the implementations of the typeclass for integers and strings. This is the typeclass instance for integers. The implementation uses an if expression. The expression returns -1, 0, 1. It depends on the first value, if it is lower, equal or greater than the second. The implementation for strings instead just uses the existing comparator method, already available. Now, let's deduct the implementation, applying the same transformations we already saw before. We want to be able to apply the typeclasses when we simply use the operator with integers. We apply now one basic Scala rule, which transforms an operator application in the method invocation on the first member. Since integers do not have our method, an implicit conversion is applied. So we need a method able to wrap the integer in an object having our methods. Furthermore, the typeclass instance is applied as an implicit parameter. Now, what we really want is the code, able to expand the wrapped code to this actual invocation. The actual implementation is actually pretty easy, but we need two elements, a wrapper class, and the implicit conversion method, which returns the wrapper. The wrapper is a class, taking two parameters, the object we want to wrap, and the typeclass instance. Note that, while in the trait the method takes two parameters, in the wrapper class it takes only one, and store the first one as a field of the class. This is the implicit conversion method. It takes the object to wrap, the implicit typeclass instance, then construct the wrapper. The wrapper actually allows to invoke the typeclass instance methods. Let's verify if what we did works. The typeclass instance is correctly applied to integer. Also, the typeclass works for strings. The typeclass does not work for persons until we provide an implementation. So here is the implementation. We choose to compare persons by alphabetical order of their name. As you can see here, now the implementation can compare persons. All we did was to add an implementation for its type. The rest is applied automatically as long as we follows the typeclass pattern.